All right, so this is similar to greatest common factor, a little bit different. So they're close, but easy to confuse one with the other. So I'm kind of have to pay attention. This is called least common multiple. Least common multiple. A multiple of a number is the product of the number and any whole number. So, for example, multiples of 3 would be 3, 6, 9, 12. Multiples of 9, so 9 times 1 is 9, 9 times 2 is 18, 9 times 3 is 27, and so on. So those are examples of multiples. A least common multiple is the lowest common multiple of any given set of numbers. So we could do it one of two ways: by listing out all the multiples. So that would be, for example, like 3 and 5, 3, 6, 9, 12, 15, and 5, 10, 15. So obviously the first multiple you come to that is in common is 15. So we're looking for the lowest common multiple here. I like to start with the bigger number first and then kind of think in my head if anything can go into that. So I think like, okay, 10, nah, 9 can't go into that. 20, no. 30, no. 40, no. 50, 60, 70, 80, you're probably getting the idea. 90. So obviously if you want to list a few and do 9, 18, 27, and then I think we'll know 9 times 10 is 90. So our least common multiple is going to be 90 in this case. That's an example of listing them out. In this particular example, it was just these two multiplied by each other. That's not always the case. Let's take a look at 3, 12, and 15. When you have three numbers, again, it has to have all of them in common. So again, still like to start with the biggest number, see if the other one can go into them. So 15, can 3 and 12 both go into 15? No. 30. 3 goes into 30, but 12 does not, so that's out. 45. 12 going to 45? No. 60. 15 goes into 60. 12, we could think of some there. So 12, 24, 36, 48, and 60. So I think we have a match. If you're doing these for your homework, you can just list out a few, and then for the other ones, you can, if you already know what it is. Okay, so that would be listing it out. Again, I don't like that method as well. I think it takes a lot of time. We can use, kind of like we did before, the greatest common factor with a little bit of changes. Or like we did with the greatest common factor, we can use the factor trees. So let's go ahead and factor this out. A couple different ways to do it. So find the prime factors first. Okay, so list them out. So here's the change. Still looking to circle prime factors they have in common and write down the number kind of as a representative. So we're going to write down our pair of 2's. Okay, so if this was greatest common factor, my final answer, we got to circle the 3's, would be 6. I would say 2 times 3, my greatest common factor is 6. So that's not what we're trying to figure out. We want to know the first multiple of these that fits. And so instead of doing that, after you circle the common ones and only write down one from each bubble, okay, notice we wrote down one from the 2's, one from this pair of 3's, then you write down everything that's not circled, which would be the 2 2's and the 5's. Then you multiply that together. So we're going to have 2 times 3 is 6, times 2 is 12, and then this would end up being 10, and so it would be 120 would be the first time, the first multiple that these both could go into. Okay, so let's do another example. Kind of split the page here. $72. So we could do 8 and 9, 3 and 3, 2. I like to circle them just so I don't forget anything. 96. 96 we could divide by 12. 12 and 8 actually equal 96. So then we got 3 and 4. 2 and 2. Sorry, that's a 4. And trying to save myself some space here. Okay, so let's not forget some of these 2's. All right, so now I have 72, 96. Again, you're thinking the first number both of those are going to go into. So this is going to be a pretty big number. So here I got 3 2's and 1 3 and 2 3's. I'm sorry. Here I have 1 2 3 4 5 2's and 1 3. So again, we're going to circle the ones they have in common. And looks like they got a set of 3's. And write a representative down. Okay. Then we're going to write down everything else that's not circled from both. So it's like they got a 2 and a 3. It's a pretty big long list there. So we got, multiply it all out. So 2 times 2 times 2 times 3 times 2 times 3. Sure did my math right here. Okay. 2 times 2 times 2 times 3 2 times 2 3. So we get 288. And a quick way to check, you could divide that by 72, see what you get. It goes into it. Divide 288 by 96, it goes into it, so you're good to go. All right, 3 is a little more tricky here. First things first. Get your factor trees, 2, 2, 5. Tried to make them fairly easy for you today. Okay, so here's the big difference. Circle anything they have in common. Any pairs, it doesn't have to exist in all 3. That's only for the LCM. It does not have to exist in all 3. So for example, that's a pair, I write down 1. Okay, that's a pair, I write down 1 of the 11s. And let's squeeze the 5s in there, and that's also a pair. So the only thing I'm not left with is actually that extra 2. So let's see if that comes out making sense here. So 2 times 11 times 5 times 2. We get 220. So can all of these go into 220? That would be a good place to start to check. First divide by 55. Yes, that goes in evenly. 220 divided by 22. Yes. And 220 divided by 20. Yes, so they all go into it. Okay, so that's the big change there. It does not have to exist in all 3 of them.